guys, Gadget UK here again. Out of breath from carrying these two. They weigh quite a bit and they're in immaculate condition. So yeah, have you not guessed from the title already? Two Acorn Archimedes A3010s. So these kindly came from Xavier over in France. I tell you what, that guy can really package things. These were really well packaged. You can see, look at that, even the plug is well packaged there. So yeah, they appear to have arrived in good condition, and yeah, they're in not bad condition in general, these, aren't they? In the special edition here, you know, they've got these this thing's, it's a sticker I think, stuck on here. So originally that belonged to Yarm, well, I don't know, it's marked Yarm Computers, that was where it's bought from perhaps. Yeah, so we'll have a look at this one first. So the badge is a little bit yellowed, it's in pretty good condition, there's some marks, sticky stuff on here, that'll clean up I think. So you know what? That again is in pretty good condition. The keyboard looks immaculate here. Now, first inspection, both of these are missing the button here, but I've got a load of these spare actually, so that's not a problem. Looks good around the back. It's got the shield still here, that's interesting. It must be, it's perforated, isn't it? So you may be able to just pull that out, but it's not got the cover, the plastic cover. So I'll probably get, if I can get these up and running, a lot of corrosion here. Look, oh my god, this might be this might be a no-hoper. Look at the state of this here. Yeah, if we can get these up and running, then I'll get a 3D printed piece for that. That has me worried though. Are these both going to be beyond? Yes, we got usually 3 screws. Actually, the screws are missing, so I've got no screws there. So let's approach it from the back, and then it should sort of hinge. There we go. Like that, I think, and up and off. There we go. So yeah, the clips have certainly seen better days on the back there, but they're all, well, most of them are alright. There's one broken off there, look. Anyway, let's just put the lid out of the way. Yeah, oh my god, there's me thinking these might be easier than a 3000. You can see lots of corrosion down here, all around here, so the caps have leaked and stuff. The interesting thing with this particular revision, these are not SMDs, you know, the 3020 had SMD caps, so it might not be cap leakage, it could just be the battery. The battery seems to have just leaked here, doesn't it? It's gone around this chip here a bit. Is that the main ARM chip? ARM 250 I think it is. So anyway, the next thing to do is get the drive bay out, obviously the keyboard as well. Yeah, so just rotating that around, there's no screws holding the keyboard in, so it should just lift up over its points, and there's a point broken off there. I'm going to need to carefully disconnect the ribbons here, so I'll just do the back one and then the front one. Let's have a look at those in a sec. Carefully pull this out because it can get restricted on the sides and you can damage the flex ribbon there. Yeah, so inspecting those, that one looks alright and that one looks alright, so yeah, that keyboard I think is going to be no worries at all. And there are usually then 3 screws hold this in, but that's missing screws, so we can just pull, this whole thing should slide forward, you know, the whole metal bay there slides like that, and then we can lift it up. Let's disconnect the power for the floppy drive here. Yeah, lift that up, disconnect the floppy drive here. Ouch. Ouch, ouch, ouch. So yeah, it's got a weird colour here. We've obviously got a lot of corrosion at the back here. Ouch. Yeah, I think what I might do with this actually is get this end of the board here, as much as will go into the ultrasonic cleaner, you know, just on its side, just to clean this area super thoroughly. But before I do that, I'll clean up with vinegar, cotton buds, IPA, have a good scrub around, do it on the desk first, but then soak this entire end in the ultrasonic cleaner, just to get any contamination around from this RAM, because if you've seen previous videos, you get a little bit of the electrolyte from the battery leaking down here, and you can get weird RAM faults, red screens and the things. Yeah, it's pretty bad up here though, look. Yeah, I'm not even going to power it on at this stage, there's no point. Powering on a device like this, yeah, where you've got corrosion, you may want to, just to see what the state is, yeah, but we know it's faulty, both of these are faulty. there is no point in testing it. There's none whatsoever until you've cleaned all this off. Because what can happen, you can worsen things. You know, in the time that this was last tested and it's been in storage and I've been waiting to look at it, a ground connection somewhere could have broke, and then you can get a latch up fault when you come power it on. So yeah, when you've got a high level of corrosion on anything at all like this, don't power it on and try it. It's the worst thing you can do. I did that on one of the 2000 repairs there, where it was moderate. Maybe you could argue if it's moderate and it's cleaned up, you could then maybe try it. But something like this here, any of these Archimedes that I've worked on with leaked batteries, and you know, some of the Amigas as well, there's no point in testing it when it needs so much doing to it. Yeah, so the board is held in, I think, with the transformer screws. You know, so there's a couple of screws that go sort of on the underside and they mount into the transformer, or this, I think, because that ain't moving and I don't see any screws holding the board in. Yeah, so coming from the back end of that Amiga 3000 repair there, I thought I was in for something a bit more easier. I'm not so sure at this stage. There's a lot of corrosion on this. I mean, it's right up here across all the ports and everything. But anyway, let's just give this a go. So I've got a Allen key here, a hex one. There we go. Yeah, just to undo these here. I may have used a Torx bit before. You'll probably find it will fit if you get the right Torx bit. See, I always thought the batteries on these 3010s were less damaging than the ones on the 3000. And I think that is the case. They always seem to do less damage, but I mean, this is the worst 3010 I think I've seen so far, isn't it? It's worse than that 3020. So this must sort of come forward and out. I just think the corrosion at the back's holding it on. There we go, yeah, it is. And obviously it's the weight of this here. So that's that out. Ouch. Look at that. Let's put it on the bench. Gonna need to get a hazmat suit, I think. Yeah, so the next thing I need to do is separate. Oh, look at this. The board from this shield here. So yeah, this is where if you've got a tool, use that dedicated tool. It just makes everything so much easier. Keep your parts in some sort of container so you don't lose anything. There's one on that, we'll get that off with the pliers in a sec. I think if it wasn't for this here, I'd feel quite positive, but every one of these ports could need replacing. I need to go wash my hands in a minute, I think. So the next thing is to just undo that, like that. And obviously the other thing we need to do here is contemplate what happens with the mains lead here. So I think, yeah, we'll just disconnect this. So I'm going to just unplug the connector down there if I can. There's very little room in there. There we go, that's that off. Disconnect the earth. That's that. And then I think, hang on, is there another screw there? No, there's a screw that's underneath that, I think, that holds something on somewhere. Why is that attached now? What's holding that? Oh, it was just stuck, that's why. So, yeah, all of those there were just stuck to that shield. Ouch, that is probably the worst I've seen of one of these pieces of shielding on any of the systems. So anyway, let's get that on the bench. Yeah, so case parts, shield, keyboard, etc. all well out of the way. So we can now just focus on this. And oh boy, we're going to have our work cut out for us, I think, here. There are so many fine traces here that look affected, but it could just be surface level stuff. You know, you don't always get traces completely gone on these. The problems from what I've seen so far tend to be the conductivity the electrolyte from the battery provides, you know, and it's all up here. It's all around the arm, around those two sides. And so we'll just start with some distilled white vinegar here. And let's just see what it looks like. And a lot of this is superficial, actually, I can tell straight away. It's just, you know, you get a bit of fuzziness, it's attracted to all of the solder points and things on there. So far that's not bad. It's going to get bad over the left side here though. Yeah, that's not bad, actually. Let's hope for this one. No, this is where, yeah, it's getting crusty here now. It's strange, isn't it? You know, because look at the colour of the cotton bud. it's not actually too bad. When these are really bad, that cotton bud would go like really green because the solder mask paint comes off. None of that's happening here. This is superficial. So the stuff at the back here, this could just be traditional corrosion, just based on where it's been stored. You know, if you're collecting these to repair them, you may store them in a barn or a shed or an attic or something. And I think that maybe that's what this is. This is rust rather than corrosion based rust. I think that's what that is. So anyway, let's just continue around this. Floppy drive cable's probably going to have to come off, you know, the connector. Yeah, it's making my hands go weird, this, like, skin funny. So yeah, these components here are pretty affected. And this is why you need a toothbrush, because I can't get in between those with the cotton bud. Not at all. You see it's going a bit white afterwards. That shows that the corrosion has sort of bit into this area. If it's just like superficial surface stuff, it wipes off and then you dry it and you don't get a white streak. When you get the white streaks, it's where it's started to take hold. You know, it has affected the solder mask paint. It's just this bit here, which is what you'd expect, because this is all close to where the battery would have been. The battery would have been here, by the way. Yeah, and even though we're nowhere near like testing and stuff, I am going to just clean here at this stage as well. Vinegar. Yeah, I don't think it's done much to the ARM system on the chip there. You know, it's got the ARM CPU. Runs a bit faster, 12 megahertz is it, or 12.5 versus 8. But you've also got like the VID-C, the IOC, the MEMC, and everything merged into that. And you can overclock these. That's another video I think I've got coming up. Again, thanks to Xavier. Yeah, so the traces here are pretty badly affected, just where it goes into these resistor arrays here. But we've got loads of wires here. Look, this is going to be really easy to test and beep out on each one of those to determine if they get into the resistor arrays. And then of course probably going to need to do the same thing or a similar thing on the other side to make sure that where they come out they go to these various caps and resistors here. But I mean, this is parallel port stuff, isn't it, I think? So you know, as long as you don't get a short somewhere, that's not going to stop it from booting. Look at that, it's just terrible. Yeah, so fiberglass pen might be the next thing to bring out, actually. Try the best to not block it here. Just gently go like this over the solder points, you know, the tops of them a little bit as well. It's going to block now. Like that. And clean with the vinegar again. And some IPA. Yeah, you can see how bad it is here, and you see all the little thin traces there that come to these resistor arrays. Well, you can just about see for the glossiness of the corrosion and vinegar that's still on there. So that area is pretty bad, and look, yeah, it's pretty bad all the way along here. This has just been cleaned, bear in mind. Look at all the white stuff on there. And there, this is why it takes a number of passes, and obviously got to reflow all this stuff really. So that connector might need replacing. And obviously there was a bit of corrosion around those two sides, but that looks alright. It was just superficial surface stuff, a bit of fuzziness and nothing else really. Yeah, reflowing again around here, I think. That little hybrid or whatever it is, yeah, it's going to need cleaning on top. It looks dirty, and the points where it joins the PCB, bit of corrosion. And when we get further up here, things start to look normal really. You know, everything looks alright around there. And over by the ROMs and the RAM sockets and the RAM chips, yeah, it's kind of looking alright there, isn't it? But as we go further up, yeah, the resistors next to the ADC connector for the floppy drive, and obviously where the battery was. So I don't know, it's I think there's a good chance it's going to work, but look at these. Yeah, could be lots of issues with ports on here. So I had a little scrub with a fiberglass pencil around some of these things, those caps there, that component, you know, that chip there, not these ones, not the stuff there. So I mean, it's looking a bit cleaner than just this bit here. But anyway, I'm going to get some more vinegar, and yeah, I'm just going to soak this stuff actually you know, just leave some blobs of it here just for 10 minutes and then come and start with the fiberglass pen again. And obviously all around this stuff. Chips I see here. Provides your floppy drive interface, I think, and, you know, handles some of the stuff on the BD bus. So it's about the BD bus so the cows go home. I think it's usually a problem on nearly every other Archimedes I look at. Yeah, anyway, I'm just going to leave that for, like I said, 10 minutes or so. Then I'll come back and I'll start brushing around, well, mopping up first, then brush around with some IPA. Blow dry the board down with some hot air, and then, you know, rinse repeat a few times with IPA. I think the next thing I'm going to do, while that's just drying a little bit, I've mopped up most of the vinegar there, but there's obviously still going to be some on the board. Just going to use the wire brush here and just have a bit of a clean here, because then I'm going to get loads of IPA and brush this way, including cleaning these ports. The ports may need further clean-up work later, and we may need to replace them, but from prior experience you tend to find that if the traces are alright, just cleaning these up this way is often sufficient with these. It really depends on how many hours you want to spend. I really don't want to be spending 100 hours on this. But at the same time, we'll need to do exactly what needs to be done to it. So if these need to come off and be replaced, obviously I will do. Now my other thought actually while I'm doing this is it could be cat pee. A cat could have peed on this. And I'll tell you why. Because I could smell cat pee when I was unpackaging the box. It could have just been where the box was stored or something around there. I'm sure it's not one of my cats that's peed on it. Another reason for doing this at this stage is because, you know, wire brush, you're going to get some wire strands. I'd rather be doing this sort of stuff now, and then we're going to be cleaning, we'll get any strands and contamination off. Right, so the ports are looking super clean now, so I'm just going to disconnect this IDC connector here. Once we've cleaned up like this all around this area, I'll then get some flux on, well, after I've cleaned it, and then we'll start to reflow some of this stuff. So these little caps here, just circle around the surface. Look at that, they look way better. And if you do stuff like this under magnification, you'll be able to do a much cleaner, more accurate job. Anyway, I'll report back. Right, that concludes about 15 minutes of fiberglass brushing all around here, which is why it looks so fluffy and dusty. You could just hoover at that point, actually, and get rid of a lot of the fiberglass dust. You don't want to breathe this stuff in, and it can irritate skin. Anyway, so we're just going to have a clean around there with cotton buds, and then I'll IPA and toothbrush all this. So I did clean over this as well earlier. You've got to be careful because it's got some pretty sensitive components, these little black strips, the resistors I think. So yeah, corrosion could have damaged that. So I've got to hope it's going to be alright. But you can see there it looks pretty white. You know, they get like a white dusty sort of appearance, don't they, when the alcohol has affected it. And then just work my way across here. May need to do some of the things up here, maybe this edge, these will definitely need doing here. And as I say, I'm probably going to take that, well, we'll take that off. I'm not leaving that on, there's going to be all sorts of awful connections under that. And as a result, the floppy drive isn't going to be doing very much, is it? Another reason for not testing, obviously, you know, we could have killed the chip size C. That could have already died as a result of someone testing this post-corrosion. So, yeah, you always want to err on the side of caution when you've got so much corrosion. Yeah, so I'm not sure if the soldering is up to temperature. I think it is actually. We'll get a wee bit of solder containing flux, it's leaded solder, and that's what you want to use on an old board like this.
Yeah, so I'll need to use some magnification. Hopefully my ear is not blocking the shot here. Yeah, and this is the thing, I might need to use some braid to remove the solder and apply new solder, because some of these are not, that second pin there is not melting at all. So yeah, I think that's what I'm going to do actually. I'm just going to use some braid here and we'll sort of, you know, just press gently, heat each pin and drag across. The friction of dragging sort of removes the crustiness to the top of the component. And you could argue take these things off completely. Get some fresh solder. And I'll try heating these again. Yeah, the solder is flowing now. I mean, don't get me wrong, the pins still look awful, but the solder is flowing on the pad and on the pin. Yeah, that corner pin needs more work. Just get some more flux in there. Yeah, there we go, even that pin is reflowed. Let's try that cap there. And again, the solder is awful, so I'm going to use the braid, remove the solder. You know, there's different ways, as I say, you could remove all of these components, replace them all. But I guarantee this will work and will be reliable doing it the way I'm doing it here. There we go, sucky, and then add a bit more solder. That's better. Hopefully, oh hang on, it's lifted up there, can you see that? That is a result of the solder point, well, heating it up, and the solder point on the other side. Just going to push it down with my nail. Yeah, there's my little tool gone. Yeah, the solder point on the other side has just come loose. This is why you need to reflow these, because the solder, you know, obviously breaks down. So yeah, we'll just reflow the other side. Anyway, I'll just reflow the other side of that off camera. You can argue it's a bit of a waste of flux, because if I just continued on, some of the flux is almost in the right place there. You get stuck because it's pretty sticky. And of course, something else to check here is on connectivity tests in a minute, and resistance. To test these resistor arrays, test the caps you've reflowed, any resistors. Just make sure those components aren't, you know, caps aren't short, resistors aren't just open circuit or something, or, you know, look like they have the correct resistance. But anyway, you get the idea. So we've just done a few little things around there, and it starts to look a wee bit tidier. Right, so I kid you not, it's taken me an hour and a half to do that one bit there. It's incredible how many passes and things I've had to do. I've just cleaned it again with the fiberglass pen after soldering all the stuff, just to get rid of any little bits of black marks and corrosion, etc. But I think you'll agree that is looking so much better there now. Yeah, and I think that that is going to be the hardest bit. As we get further across to the right, it's going to be a little bit more forgiving, and it's probably just going to be you know, one or two passes, you know, pass with some flux and solder, and then just IPA and stuff, and then it'll probably look pretty good on the right hand side. But this bit here, so close to the battery. The next thing I'll do once this is dried is just do connectivity tests on the resistor arrays from the wires up there. I'll show you some of that perhaps, and from the side, you know, the output side here through to these caps and resistors and inductors, whatever they are here, maybe to the port. Yeah, so that port is going to need a bit of a clean somehow, maybe with more vinegar, because the pins on the inner row just look a bit green. It's going to be one of these where it's going to go through a couple hundred cotton buds, I am sure, and the board is probably going to be horrible at the end of this. I don't know, you know, kind of like a dull matte. You can see it doing it here. It goes all matty and horrible, and that's just what happens when the solder mask is damaged. So I tested these resistor arrays here, 33 ohms across all of them. there are numerous traces damaged here. There's like, I think one here on this one, comes from up here. On this one, there's like 5 or 6. There's only like 2 or 3 connections that actually make it to the vias. The traces are so fine that it's like, it's right there up with the MVS in terms of trace thickness, and they're right next to each other. They're almost a trace width apart. What I'll end up having to do is, you know, route some pretty fine coil wire down here to each of the points, try and follow the traces as near as possible. It's going to be a bit of a bodge, and then use solder mask paint to, you know, cover over that stuff. And there's a few bits around there that I would cover with solder mask paint anyway. It still looks a mess. Anyway, I've just got some flux around here. I'm going to reflow these now. The thing I'm most concerned about is this. It's one of these things where the covering is wiping off, you know, just a gentle wipe with a dry cotton bud, and the green coating's coming off. And the little black, I don't know, you can see them little black silhouettes. Listen to it. These little sort of silhouette type things, you can see it's like a dark one there. There's 2 here. There's one there. There's one here. They're all down the bottom and stuff of the board. It's like a resistor that's been printed onto the PCB, and the covering's coming off around some of those areas there. It's like, it looks really dry and dusty. So the corrosion has got onto that, and I don't know what to do with it. I think we'll wait. We're not going to touch it at all now. I'm not going to touch it again because the coating's coming off. We'll see if this is working. I'll look at the schematics to see if I can work out what this is. I'm guessing something video related, but it could be power related or something maybe. And then I may take it off and get some solder mask paint over the whole thing, because if it does work, the solder mask paint's going to be non-conductive, and it's just going to protect it. I might even just spray it with something. I don't know. Alright, it is coming up a lot cleaner now. You can see how goldy here it is. There were loads of black specks all over here on many of those traces, and I've tested the connectivity from the vias and actually come all the way down to almost the chip. It's literally at the pad, and it's the same on this one. So I am hopefully just going to be able to join up with you know, some solder to the now exposed copper here just by reflowing these here. I don't think I'm going to need lots of wires, and there's only, I don't know, 3 or 4 on this one and 3 or 4 on this one that need fixing. And I've just been using the braid there with some, you know, get some flux on, braid and solder, and just heat, you know, drag the braid over there, just as I've shown lots and lots of times. The point here though, I learned something with, there's different types of fiberglass refills. Some of them are really, really stiff, and you get little bristles and they stick in your hands. This is one of my older ones that goes, it's really soft, but it's firm enough to scratch the copper here. But when you've, you know, gone up and down for maybe 30 seconds or so, it starts to get like sticky and spongy, and you don't get anything off. You just get paper towel with IPA and just clean. You can see it looks black on the end. Just clean the actual fiberglass brush, and then as soon as you put it back on the board, it starts to do scratchy like that. You can hear the sound. Yeah, and then I managed to get rid of all of the marks here. All the ones here are gone. I thought that some of these here would have been broken. They're not. They're fine. They've tinned up perfectly. So I don't think we've got any broken traces as such. It's just the point where the really fine trace joins the pad. That's the issue. Anyway, we'll just get some more flux on here now. I mean, it is going to be quite difficult actually joining the little traces to the actual pads if, you know, solder doesn't just bridge it. That's the thing. And I can use some coil wire to do that, but yeah, I've shown this before. Just slide the tinned braid like this, just carefully, and if you get stuck, just completely stop. Do not pull. Wait till you get to temperature, and if you're not getting to temperature, add some solder, because there you go, it'll suddenly get back up to temperature. Anyway, you can start to see what I'm doing there as these traces here are tinned. You're best off doing this under magnification. Don't hover in one place too long, or the heat may dislodge, you know, lift a trace. Right, so I've still got stuff to reflow here, still the odd resistor, still the ports here to fix, but all the connectivity here is good in terms of, like, I've checked ground, VCC, so I thought, let's give it a try. So I disconnected the power lead from the shield there, connected it up, and got an RF lead connected to the TV. The speaker here, if we could hear a sound, there is no sound, so I was just like, I need to connect the keyboard next, I think. That's normal, and that's normal, but we've got a bit of ghost in here. Is this hybrid thing here? Oop, yeah, my finger's just near that, made it reset. So
I'm not sure what that hybrid does. I just touched it and it reset, so it might be doing some clock stuff or something there. But why have we got this ghosting going on here? So I'll see if I can tune the TV in a bit better. But I think the next thing I need to do is connect that keyboard and hold down R or delete, I think. It's going to be a bit awkward to precariously balance this on something. Let's just, anyway, connect the bottom ribbon. I'm just going to leave it sitting on there just for the moment. I'll get something to stick under it. Let's just carefully lift it and stick this under there, balanced sort of in the middle. Yeah, that should do. Again, it's a bit precarious. You've got power supply here, mains voltage. Let's just hold down delete without tilting the keyboard. Switch it on. Yeah, the power LED is on there. Yeah, it's gone red, the background. Hey! So, it is up. Right, let me connect to the mouse. Let's move around. So we've got left click, right click, middle click, and we can move the mouse. And I think there's a 245 back there for that, so even though that's crusty, it shows that it's it's working alright. I guess the next thing to do is, and again, it's all going to be a bit precariously balanced, connect the floppy drive up, try a disk. So anyway, it looks like it's working, doesn't it? Looks like it's working. But I'm very pleased because it looks like it works, doesn't it? Bidding on some memory modules at the moment to try and bump this up to 2 meg. I may have a spare 4 meg one yet, but that depends on the outcome of another video. Anyway, yeah, so very pleased. I mean, that's not bad really. I've probably spent 2 or 3 hours in total just cleaning up here, you know, showing you the stuff that I've done around there, but obviously there's still an awful lot more to do on it. Anyway, because the power ports are not going to be working at this moment, the game ports could be affected by this corrosion, as could the serial. I think it's got a serial back there. So yeah, floppy drive, let's try and connect this now. So it wants to go from there, like that. So I'm holding delete. We're holding delete, that's reset everything. There we go, it's booting up. Let's look at the drive. We're into Risk OS. And now I'm trying to hold that shield up as well as use the mouse on my knee. This is going to be interesting. Drive empty. No, the drive isn't empty. It could be the disk dissection switch. Yeah, it's not even looking. So that's going to be corrosion around that connector, isn't it? Ugh, yeah, and the resistor around there, caps and things like that. Anyway, you can see we've made some good progress though. Right, so the bad news is this has turned into a much more complex repair. I mean, it is working, you saw it booted up and everything, but in terms of the parallel port, the serial port, it's going to be loads of work here. Every single connection on the top side is broken there. Even from the little, you know, capacitors and inductors and stuff that are in a big strip there. Testing the connectivity to the pins here, hardly anything is connected. So this connector is going to have to come off. And I'll probably try and replace that with something else if I can. Anyway, you can see how bad it's affected on the underside here. It's pretty fuzzy. So I'm just going to have a clean with some IPA there and try and solder the darn thing. Yeah, it's frustrating because it kind of looked like it was going to be an easy repair, this one. It's also made me wonder whether I tested the connectivity there on the previous 3010s I looked at. I'm sure I did. I don't think they were anywhere near as badly affected by the corrosion as this one. Yeah, so I don't envisage this being easy to get off actually, because of the corrosion on the other side. And yeah, you've got some pretty beefy connections here. Let's start with these anchor points. I may need additional heat here. No, it starts to flag. Yeah, that did completely block this, so I'm having to pull the plug out like that. Well, I guess this is the first time for everything. That's the first time my dissolver pump has ever refused to eject. Let's just get a tiny bit more.
And obviously when you're dealing with a point like this, you know, a larger tip, maybe go higher temperature, leave it longer. There you go, that's most of that gone. Anyway, report back. Right, I got rid of most of the solder off there now, so I'm going to use the solder station, which is nice and clean. So I'm not going to add any additional solder here, I'm just going to start down here. A little wobble and a little suck. Well, I'm really surprised. You know, there's hardly anything come out there, look. So, yeah, anyway, just for good measure, I'm just going to try and heat these points here as well. Did I say here? Here. Yeah, so I just zoomed you out a wee bit there. Yeah, a wee bit of flux around those. Yeah, it's always pleasant when I noticed that the solder station didn't remove any extra solder, because I must have got rid of it all with the pump. And I do believe that one's free now as well. Right, let's just try and have a little bit of a pivot here. You know, sort of grab these, and if we can, they're barely through here. There's hardly anything protruding. Yeah, that edge there is not really snapped off. That one is, I think. Yeah, this edge down here needs more work. Because even though you've desoldered them, what can happen is you've got your hole, the pin is like that, you use the solder station and then it just sits like that and you've got a bit of solder still. So, you know, by doing this, you snap off the edge there. But obviously, if you've got loads of solder there, you could actually pull the pad with it, lift a trace, etc. So, yeah, this bit is just the final step, really. A little pivot there. So, yeah, now the scary bit. Because obviously this is, you know, corrosion affected here. You can see straight away though that, oh look, it's coming up there, it's just this side now. Which isn't free, which is strange, isn't it? The side that looked free isn't free. What I'm going to do here, I think, is heat this and then just pull it. There we go, it's just freed up, I think. There we go. Yeah, so we can clean up that. I'm not sure I want to reuse it. Yeah, and ouch. And this is the thing, so what my approach is going to be here, before I actually remove that, I thought, how am I going to fix this? Because the traces are on the top side, and all the components are on the top side. I think what I'll probably do is run some coil wire to each of the pins, you know, secure them all down with some UV solder mask. Before I do that, I need to fix everything around here first. You know, the connections coming out of the resistor arrays are all broken. Some of the connections on these caps are broken going that way. But anyway, it's killing two birds with one stone, because if they're broken at the point where they join the circular pad there, and they're broken at the point where they come out of here, it makes sense to just have a wire going straight through. And that's what I'll do. I'll go through the hole, through the hole, through the hole, secure them all down, test connectivity at that point just to make sure there's nothing shorting, set the UV solder mask, and then get the connector or a new connector back on. Ideally a new one, but I don't know that I'm going to be able to find one that fits, you know, that's going to be suitable. Anyway, I think we'll clean with some vinegar first. There's nothing underneath these here, so there's no reason to take those off. These three, however, I'm going to remove because they've got the same sort of problem with the serial port to a lesser degree. So I'm going to remove these just to, you know, fix any traces and wires and things underneath those. Yeah, it's going to be a two-part of this one, I think. pass with the vinegar. I'm then going to use the fiberglass pen here. So those have just been soaking in a cap of vinegar for about 15 minutes, and all of the greenness and orangeness is gone. It's incredible, absolutely incredible. Some bubbles came out of here, so yeah, there was a little bit of contamination in there. Still needs a bit of work with the fiberglass pen underneath, but these are going to be alright, I think. Yeah, they're going to be alright. All of the stuff's gone off them. It was that inside row that was affected, and yeah, it's cleaned up nicely. So I'll just clean those now with some IPA just to displace the water. When I say water, I'm talking about the vinegar. It's probably like, what's the word? Distilled water used in vinegar? Maybe not. Anyway, it won't do any harm just to get some IPA in there to displace. Just getting creative with the cotton bud here. Got some deoxit on it. I've squashed the end a little bit, and it's just wide enough to just marginally squeeze between these pins. Like that, and I can slide them down. There's just a bit of corrosion just on a couple of them there, but they're mostly still totally gold plated. Yeah, there's a little bit of dirt come off that. So the next thing is to do the same here. Clean with a cotton bud initially. Fiberglass pen, just to freshen the surface of the solder up. Despite the fact that pins are pretty free on this side, and I think it's just because there's so much corrosion on the underside of some of the points on here that it's still joined. Yeah, just to try and get my extractor onto this. There we are. So, yeah, no pads or anything there. Yeah, as crazy as it seems, you know, always consider like a hybrid type of removal where you use a number of different things to get something off a board, and you can just maybe mitigate, you know, risk of damage. Look at the state of that. This is why it wouldn't desolder properly. Yeah, and hopefully this is the reason why the floppy drive isn't working and not a fault with the chips IC as a result of this corrosion. I mean, you can argue I didn't follow my own advice, you know, about fixing traces and things before you power something like this on. You know, if the chips IC was damaged now, it could be from me powering this like this and to try and test the floppy drive when you've got all that there. Anyway, I think it's unlikely. From experience of working on these, you tend to find when you get that level of corrosion, the floppy drive won't work, and generally just to clean up here and fix anything that's you know, damaged will solve it. I'll go see if I've got another IDC connector. It might be a black one. And you know what, I'm going to have to check back the footage because I can't remember which way round it was. Like, was it with the key that way? Yes, it was actually, because the broken part, someone's broken this previously. You can see the pins have all bent there, look, as a result of the removal. Anyway, that could be reused because the pins are actually okay, apart from these that just need straightening out. Just looking through my spares, I've actually got some replacement ports here. Both you know, the 25-way and the 9-way D-type. So I'm just going to measure these up on the board. There's a bent pin there actually, look. Yeah, I'm going to measure these up just to see if they will fit. It's probably going to be the same with this one. I think this should fit, assuming the pins are straight. Yeah, that's going to fit as well. So yeah, we'll replace both of those then. Anyway, I'll just keep these as like last resort spares for something. Alright, I've almost had enough for one day. I think what I'm going to do next is remove that cap. I'll tell you the size of those. Those two back there. This one, because I melted it. I always melt that cap. I don't know what it is. Every time I come across one of these, I melt that. I've got some of those because I've got the one to swap out on mine. I don't think I ever got around to swapping it. I can't honestly remember. I'm going to order one of these because, let me show you. This is well and truly balked. There's corrosion up and down every single one of those pins, even though I've straightened the pins out. It's beyond. yeah, and then in the next video we'll pick up when some of those parts arrive. I'll reflow some of the stuff around here, the pads, the traces, etc., and they're going to have to start to fix things because there are a number of connections here broken. Yeah, they look fine, they look like they're joined, yeah, but you measure on, I'll show you, you measure on continuity and it's exactly the same all the way up here, all the way on these caps, on that these resistors here go into these caps. This side here of this one I still need to do, that side of that resistor array there I've done, all 8 of those now connect. And I can show you what I mean here if I just start from one of the probes up, and one of the points up here, and I'll try and find it, there we go. Yeah, so from the first via here, so the first pin on the resistor array we've got to join, and step along to the next one. It's a good idea to do that, and then you can check for sure. So then we go to the next one, and the next one is that one, and then the next one, which is, actually the third one's not joined, man. Yeah, I had to bring the magnifier in there. The third one is that one. But anyway, the point is, all the wires here go to the first 8 there. Then we've got a 9th connection that comes through the middle. That's not joined, so I'm going to need to fix it. It's you can see, well, you might not be able to see from there. I'll show you a macro there. I fixed the trace there, but it also breaks down here. That'll fix the 9th one of this bus of connections. And then I need to do 4 or 5 on this one here. Yeah, in the same way that I did these. And all I did is use a piece of coil wire from the trace that's exposed with some flux up to the actual pin. So yeah, this is the thing, you could have separate wires from here all the way over there, but I don't want big wires going on the board. You know, I can cover over these little fixes here with solder mask paint, and I'll get some over these here and these when I've done those. But then we're going to do the same thing on this side, so all the connections, the same thing there. Check every single trace that comes through and do the same thing with these here from the components. You're going to have to have a piece of coil wire through the hole. Secure everything with solder mask paint and stuff, you know, the wires will be through the holes, then get the connector on, solder it on, then test the connectivity. We may find 1 or 2 are problematic if I'm not careful. It's just going to be a nightmare, isn't it? It's going to take me hours. It's going to take me hours to do the parallel port, and then we've got not as many connections on the seal port, but we've still got the same sort of problem. So these 3 chips here are going to have to come off because we've got the same issue where the fine trace joins the pad and it's broken at the point where it joins the pad. So yeah, and then by the time we get over here, I've tested connectivity, everything's good. Yeah, so more cleanup work is needed over there, but it's these things here and this that are balked. And here we've got 1, 2, 3, 4. I mean, these, so technically some of these are just jumpers, but I'm going to patch them anyway because there could be a component missing. We've got 4, 5, 6, 7, 8, 9 or so traces there, and about 7 of them are broken. And then of course the ones for the battery, and then we've got these fine ones coming down here to these wires, which probably go underneath to this or to the parallel port, and those are balked, these are balked. Yes, I know we've covered the A3010 a few times now, not especially exciting in the sense that we didn't really cover any new ground in this part. There's still an awful lot to do in part 2. I'd be interested to know what your thoughts are on approach. Would you reuse the original ports there? And I guess maybe suggestions on how you think I should go about fixing all the dozens or so traces that are broken. Anyway, huge thanks to Xavier. So I do hope you found the video interesting. If you'd like to support the channel, please leave your coffee and Patreon links down below. Thanks for watching, and I'll catch you in the next video.